Hey guys, what's up? My name is Gabe and this is Games with Gabe, and this is the next episode in the C++ for Java developers series. So in this episode, we will talk about preprocessor directives. By the way, if you want a solution to this header version of this challenge I gave in the last episode, let me know in the comments because I don't plan on providing a solution since the logic is all the same. It's just we're changing around the way you execute that logic. Anyways, let's talk about preprocessor directives. We're going to go through a few different preprocessor directives. We will go through hash define. We will go through hash if define and hash if not defined. We will also go through hash if, hash elif, hash else, and hash end if, which all go together. And we'll go through each of these one by one just to see what they do. So the first thing, which is commonly called a macro rather than a preprocessor, is a hash define. And you can basically define anything you want. So say I wanted something called pi, and I wanted to define this as 3.1457. I don't really know pi, so that's probably wrong. Okay. The way you do this is you write this on a single line, and you type in what you want the name to be, and you type in what you want that value to be. No equal signs or anything, no semicolons, just straight up like this. Now what ends up happening is, if we wanted to print this down here, we could say pi is, and then I will format this as a float, so I'll give it 4 decimal places. Then we will just go ahead and type in pi like I did up there. And macros are usually defined in all caps just to differentiate them between regular things. So if we were to compile and run this, let's see what happens. All right, so I am inside of our directory. So if we just go ahead and say build.batch, we get it built. It is built correctly, nothing wrong there. Now, if we were to go ahead and run bin/main, we get pi is 3.1457, which is probably wrong. Don't quote me on that. Anyways, what is happening here? Well, basically what this is doing, the reason these are called preprocessor directives is because during compilation, just like we have this hash include and it copies anything in this file and simply pastes it over this thing, the same thing happens with these. We can define our own copy paste operations. So you can say something like, hey, pi is this. That way you can give a constant expression a more descriptive name. So during pre-processing, before it actually starts compiling, it'll look for all of these and it will simply paste this over this. And let's see if Visual Studio Code actually, yep, it gives us a hint. So if you hover over these types of macros, it tells you this expands to, and it'll say 3.1457F. This tells us, hey, when this actually finishes expanding, this is what the final pasted value will be. And this is useful because hash defines can get more complicated. You can also hash define something almost like a function. So let's say we wanted to do a compare function, which takes an AB, and this isn't really a function. So don't use this like a function because you can have weird cases come up. So what if we wanted to do this and we just wanted to do A equals B? Well, we could do something like this, and it'll take in these two things just like parameters, and it'll paste them over here. Now it gets dangerous because notice how we don't have these wrapped in parentheses or anything. What that means is if we were to use this, it could go wrong, right? Because if we were to say something like A is, let's do this. Well, if we were to say compare 5 equals 5 to 2 equals 3, what ends up happening is this expands really weird. So look, this expands to 5 equals 2 equals 3. That's not quite right, because what we really want it to do is compare, does 5 equal 5 equal 2 equal 3? So one way you could safeguard against this is you could put this in parentheses just to make sure that gets operated on first and this on parentheses. Now if we check this out, we get 5 equals 5 equals 2 equals 3. So this just goes to show as one example, don't use these liberally. These were more of a C construct used to get around things like not having templates and all sorts of stuff like that. But they can still be used to good use in C++ in certain scenarios. Anyways, if we were to run this though, we can see that this works like you would expect it to as well. So if we compare 5 to 7, we should get false, which would be a 0. So if we just print out that as a number, and then we build and we run, we see pi is 0, which is definitely not true, but that is true. 5 does not equal 7. And then if we change this to 5 equals 5, we should get a 1, which we do. Right there. Okay, so we get 1, which is true. Last thing, macros can also take in variadic arguments. So say you wanted to write something that takes in a variable number of arguments, you could do ... And then what you could do is reference that ... as VA args. Okay, so say you wanted to printf, and we'll actually give this a format first. So we'll say this takes in a format and a ... and I'll just call this print instead of glue. Then we can go ahead and we can go into here and say print format and then underscore VA args . This is a special macro which expands whatever is in this ellipsis into here, right? Okay, so it works exactly the same way as it would in a function. You see this takes in a ... This basically expands this ellipsis. Now, if we wanted to see how this works, we could actually just say print, and then instead of doing this, we'll print pi again. And you'll see that we get no errors. And if we actually look at this, it says expands to printf pi is %d 3.1475f. And we could expand this further. And my name is, and I'll put a %s for a string, and then I will go in here and say Gabe. So we now have 2 arguments in there, and this expands to this. So you can see that's literally just pasting in whatever extra arguments we put into this VA args parameter. And if we run this, we will see that it also runs as you would expect. And forgot to change this from a D to a 2.3F. So make sure you change that, otherwise it will complain because that is not correct. Okay, so then if we run this, we get pi is 3.146 and my name is Gabe. Cool. So defines can take in arguments. It can take in variadic arguments, and you can also do some cool things inside of a define that look like this. So we can define something called glue A to B, and then we can just do A ## B. What happens here, and it's going to put them together like this for whatever reason. What happens here is basically if you pass into strings, and I might be wrong on this, but it could be any type. Yeah, and so this will work with anything, right? It doesn't have to be a string. It can literally be anything. So we could type in glue, and then I'll say print. I'll say print, and then in here I'll say whatever we had in here. So let's see if this works how I'm thinking it will. So if we do this, yep, okay. You see we get no errors, and we'll have to put a semicolon at the end of this too. What does this expand to? Okay, so if we take a look at this, it expands to this, which is pretty cool. What's happening here? Well, basically it's taking an A, which is print, all caps, and then the ## concatenates it. So then it's literally just putting this parentheses right beside whatever this thing is. And then what ends up happening is we get this macro, which then expands to this, which expands to our final thing. So if we look at glue, we get our final expansion here. So this is a more complex macro for sure. We're using something inside of something inside of something. We could do it the other way around. We could say print, and then say we want to concatenate 2 strings. Well, we could do that too. So if we do hello, and then we get rid of that, world, and I'll put a space there. And we want to glue this together, right? So we say glue that. Well, what happens in glue? In glue we get, well, it's not going to tell me what that expands to, but if we look at print, we get this. We get hello, quotation, and then we get quotation here, world. And then we get a comma because of this. Okay, see, this is another thing, right? It can go very wrong very quickly in macros. So if we want to fix that, we can just say VA args will be nothing. So I'll just put an empty string there just so that we don't get an error. But basically, if we look at this, it does hello, world, and the 2 strings are just next to each other. Now, that might look like an error to you, but let's build this and see what happens. Okay, it built just fine. Let's run it now. It runs just fine too. Okay, so that brings in another thing we should talk about in C and C++. If you want to concatenate 2 strings, you can actually say something like const char star, which is basically a string in C++. We'll talk more about that in the future. my string equals my name is Gabe. Okay. Oh, and that's cool. It actually puts it all on new lines, which is pretty nice. So what's happening here is this is actually going to, and I'm going to just print this at the end. It's just going to concatenate all this. Okay. So if we print %s and then we say my string, this will print all of this stuff out for us. And it will just concatenate all this, just like if you were doing a plus operator in some other language. Okay. So if we build, and then if we run, we get my name is Gabe concatenated together. Now, this will only work for raw string literal. So it only work if you have quotation, 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 quotation. It will not work for variables because that is a whole different story. But this is raw string concatenation, and you can use it. And that's why it worked when we said glue and we put in two strings there. All right, we've spent far too much time on define. Let's go on and move to something else. Let's talk about hash if defined and those things. So if we define a value, let's say we had something defined, Windows, okay? And this means that we are on a Windows machine. Well, what we could do is we could say inside of here, hash if defined Windows, and since we defined it as 1, which evaluates to true, this should work. Then we can print something. Hash else, we can print not on Windows, hash end if. Okay, and it's going to move them all to the beginning of the line because of some legacy things with C. That's fine. This is typically how it is formatted in most C libraries, so don't worry about that. And inside of here, we'll just print on Windows. Now, what happens here is actually a little bit different than what you would think with a regular if statement. Okay, so if we build this first of all, clear it, bin/main, we get on Windows. Then if we undefine Windows, so let's say we never actually defined anything there, then you'll see that this goes black and this one highlights because there's no macro now. There's nothing called Windows. So then if we build it and we say bin/main, we get not on Windows. Okay. What's happening is it's looking for a macro. It's looking to see if anyone defined anything called Windows, and this value could be anything. You could make it a string for all it cares. It just wants to know if it's there. If it is there, then we get this. If it is not defined, we don't get it. And we could actually undefine this too, which is a good introduction to this. We could say undefined Windows, which means now this doesn't exist. And so then we get this printed out again, okay? So we have defined, we have undefined, which gets rid of something, and we can check to see what is defined. And similarly, we can check to see if a value, a constant value, is true. So we could check something like this. If this is 1, have Windows, then we should switch to this. If this is 0, then we will switch to this. And what's actually happening here is this is a, basically you're compiling specific code, right? So if this is true, then we will only compile this code. This code gets removed in preprocessing. So it effectively deletes that, leaves this in, okay? This is useful because if you're on a Windows machine, you don't want to be compiling Mac stuff. If you're on a Linux machine, you don't want to be compiling Windows stuff. So you can do these macros, which will basically say, ignore all the Windows stuff if we're on Linux. Otherwise, include it if we are on Windows. And this is very useful in many different situations. And it's typically done as if defined rather than the just if, because we can do specific things with definitions where we define at compile time. So we can actually define things inside of build.batch, and we'll talk about that in a compiler options episode. Also important, remember, this has to be a constant compile time expression, which means you could not assign it to like a variable where we said int var equals 0. We get an error here because, well, we won't get an error, but if we try and compile this, I don't think it should compile. Okay, it is going to compile. This is dangerous code though, because what ends up happening is if variable changes by the time, oh wait, no, it's because this is an if define. I'm sorry. If this is a hash if Windows, this is dangerous because what could happen is you could say var equals 1 here. And technically, this should compile, but I don't think it will. I don't even know if we're going to get an error because of this. no, we won't get an error. But then if we run this, we get not on Windows, even though we changed this to 1. And so you just don't use variables for this. It's not a good idea because it will replace it with the compile time value, which is probably not what you're expecting it to be. Okay, so only use constant compile time expressions, things that will never change. Okay, very last thing we will talk about, I promise, is some special preprocessor macros that are sort of included by default. So these are things like underscore underscore line underscore underscore. If we look at this, let's see what it says. If we look at this, nope. Here, we'll say this takes in line, file, and date, because these are the ones that I think are most often used. You could do time as well, but we're not going to pay attention to that. Anyways, so if we type in Windows, and then I just pass in right here, line, underscore underscore, underscore underscore file, underscore underscore date. And then if we go up here and we just say printf line, well, actually we'll do a %d %s, and then we'll do a %, not sure how to do a date. So I'll just leave that as a D for now. And then we can take a look at that later if you want to. And then we'll just paste in, actually, we don't need to do that. We can just say line, file, date, right? Okay. Now, if we look at what this expands to, put a semicolon there too. This expands to 11. Would you look at that? This is line 11. File is C, dev, C++, C++ for Java, main.cpp. Look at that. That's the file I'm in. Date, March 20th, 2021. Look at that. That's today. Okay. And actually, now you guys know what time I recorded this. Anyways, though, we can use this to get like compile time information about where we are writing our code. This brings in very cool features like logging things, right? You can define a logger, an error handler, a warning handler, all sorts of stuff simply by using this. So with this in mind, here comes the challenge for today's episode. I would like you guys to write a logger. Now, I want you guys to write a macro that expands to a function call, which basically ends up logging where you wrote that thing from. So what I want to happen is you call something like log, and you can put in, this is a log, here is a number, %d, and then you can pass in a number or any other number of things. Then what this will expand to is basically a printf. Not even a printf. We'll make this a little bit even more complicated, right? I also want you to create a file called log.h, right? Inside of here, after we pragma once, you will define that log function. I'm just going to do this for now so that we don't get an error. You will also define a function called log internal. This log internal function will basically be called from this log function. And then inside of this log internal function, you'll take in some number of arguments. It's not going to be a ... but you'll have to figure out how to use VA args inside of a function and everything. And then once this function is called, what it should do is it should print basically something like, hey, this is the file. You don't need to worry about the date. So we'll do like file % or colon line %d. So that will give us like the file name colon the line number. And then I want you to, after that, like go to a new line or something. And then we'll go ahead and you'll printf like this is what the user typed in, right? So if this will just print literally whatever the user typed in. So we'll do like a tab, which is a \t, and then just whatever the user typed in here, whatever their arguments were here. So basically that is what is going to happen. You define this log function, which expands to this log internal function, which does all this stuff. Okay, that is your challenge. Complete that before the next episode, and I will share my solution in the next episode so that we can take a look at that. Anyways, that is it for preprocessor directives. I expected this to be like 10 minutes. It took 20 minutes according to my clock. So I hope you guys enjoyed this. If you did, please hit like and subscribe, and stay tuned for the next episode where we will be talking about make, CMake, premake, and build systems, how to make our building a lot easier. Okay, I'll see you then.